This meeting is being recorded.
Witam Państwa bardzo serdecznie na dzisiejszym webinarium Profitap, rozwiązanie IOTA z udziałem vendora. Dziękujemy za rejestrację. Webinarium będzie prowadzone w języku angielskim, ale pytania można zadawać w języku polskim. Postaram się pomóc w zakresie odpowiedzi. W razie jakichkolwiek dodatkowych pytań jestem do Państwa dyspozycji. Dziękuję bardzo. Rosario, please, if you can start. Thank you so much.
So thank you, Alexandra, for this introduction, but also thank Softprom to give us the opportunity today to talk about Profitap and our IOTA solution. So let me show you a few information about our company first, and then we will dig down on what you can do using our IOTA product. So first of all, who we are. Profitap is a European network visibility company. Our headquarters and R&D are located in Eindhoven in the Netherlands, and we also have a site in Strasbourg for production and logistics. Our portfolio includes a wide set of solutions for network visibilities, going from traffic access to flow management up to traffic capture and analysis. We will see more details about this, our portfolio in a bit. When asked why you should choose Profitap, let's say the main point I like to bring up is our experience in the network visibility fields and how this helps us to design a product with a strong focus on quality and following always the innovations, the new innovations coming in the ever-changing networking world. We also do our best to stay very close to our customers and partners to support them in the use of our products, but also to gather from them, let's say, suggestions, feedbacks, or new ideas to incorporate on existing projects or for new solutions. For example, just to give you an idea, one case where we have helped our customers was when we developed an hardware IOTA specifically for train environment, when we introduced the possibility to connect the IOTA, the tapping side of the IOTA, with M12 connectors. This product, designed for one specific use case, is now part of our portfolio, and we offer as a solution also to other customers. Finally, global coverage is part of our company strategies, and this has allowed us to reach more than 1,000 clients in different countries everywhere in the world. And if we look at our customers, let me show you who they are. We go from federal governments to aerospace, industrial engineering, telecom, banks, and also different types of company where they need to have visibility on their network infrastructure. So all these companies have trust us and our products to be deployed in their infrastructure. Now, let's look at the details of our portfolio. As I said, we have a quite wide set of products to cover the whole network visibility domain. We start from secure data access with our network taps in all different formats for Ethernet, so fiber, copper, active, passive, but also bypass taps for inline appliances. Then we also have solutions for traffic management optimization, our network packet brokers, so device capable to perform aggregation, replication, but also more advanced features like TLS decryption or the duplication, and soon also GTP correlation. Finally, we have also a part of our portfolio dedicated to packet capture and analysis. And this is covered by our Profishark and our IOTA, and this is actually the product we are going to cover today. Let's talk about the IOTA. This is a solution all-in-one for capture and analysis. The device has been designed to offer network engineers the possibility to deploy a single capture point where they can gather the traffic and access it and use the different dashboards to explore the state of the network, current and past, and find out the reasoning behind the problems they're looking for. Then, as soon as they need to drill down to the packet level, the device is also capable to provide them full access to the packet information. This is possible thanks to the hardware design that we have done completely in-house that includes a high-precision capture interface in different versions. We will cover them in 1 second. That has high-precision timestamp, internal storage, up to 1 terabyte or 2 terabytes, depending on the version, and then our own software for traffic analysis, and ultimately our very, let's say, efficient dashboards for visualization and traffic analysis. In particular, this analysis is capable to do flow detection, but also deep packet inspection to find out application usage and extract metrics out of application performance. Another detail maybe to add to also give you an idea about the power of the IOTA is that it's an all-in-one solution, completely self-sufficient. The IOTA, as the hardware you see here, is very high portable and is really designed to work completely independent without need of internet access or external services or applications. We have different flavors, as already anticipated. We see the 1G format with fail-safe 1G RG45 copper interfaces for capture. We have a 10G capable to use SFP plus 110G interfaces. Then we also have 2+ versions which have 2 additional features. One is the possibility to use GPS as synchronized timestamp input or PPS input, and the other is the possibility to extract and remove and replace the internal storage SSD. This is particularly useful in the case we have domains where the data is not should not leave the domain, let's say the space where it's been collected. So very high critical situation, for example. When we design the IOTA, we design a product that indeed is meant to help network engineers to troubleshoot the networks and observe the behavior of the components inside the network. And the type of deployment we had in mind are mostly two. There are different ways you can do, but these are the two that's probably are the most common. The IOTA can be, let's say, shipped out as a capture solution for a specific issue, then placed in location for capturing, storing, and analysis, and then maybe even shipped back for further evaluation. Another way to use the IOTA is instead to place it in a rack. We also provide a rack mount version to use it as continuous capture traffic and analysis, like a normal probe that you may use indeed to keep an eye on the state of your network. Now, let's start to look how the IOTA works. So we will dig down on the different use cases, and in particular, we will start with application analysis. This is a relevant use case because nowadays there is our companies use more and more SaaS solutions for their business. Anything going from managing of your coding as a software development, but also accounting, HR. Now we are using Zoom for communication and so on. All these SaaS services cover a very important part of our business. And any, let's say, degradation performance of the service can have an impact on the time of our team and ultimately on the money of our company. So let's start to give a look to the IOTA, how it looks like. So let me move on my browser. So what you see here is an actual IOTA device that I'm accessing through my browser. And we are going to start our demo tour from the application overview. As the name suggests, this dashboard uses the metadata collected by the IOTA to display all the detected applications and some metrics about them. Let's start to look on the left side. So what do we see here? We have a pie chart with all the detected applications, actually the top 40 used. We have more of them. And we can categorize them in different groups, like the chance we have messaging, we have conference, we have social, and so on. And we can use the pie chart to filter the different applications and also to observe some metrics about them. In this case, we're looking at the payload, but later we will move on the latency side. On the right side of the dashboard, instead, we have a bandwidth over time, which allows us to see whatever our total bandwidth measured is impacted by one specific application, or how is it distributed in time. Finally, on the bottom right, we see a table for the application overview. Here we have a list of the application with the detected flows and the amount of data. Now, I want to already to introduce you one of the important features of IOTA. As already mentioned, we designed this product to allow network engineers always to access to the actual traffic trace. This is possible using the download button on the top right, which will download all the traffic in the specified time range, or using the many download buttons we will find across our dashboard. Something very important to note is that these download buttons we see here, they perform some smart filtering on the traffic. In this specific case, whenever we will click this download button, the IOTA will filter out all the traffic related to one specific application and will only return you this data. This is an operation you could also do if you really want manually on the original data set. As you see, we have a data set in this case. This is a snapshot from actual network data of 11 gigabytes. But as you can imagine, this can be a very time-consuming operation for any engineer, because he will need first to identify the application traffic, then identify the flows, then extract them. IOTA will do all this with a single click. So let's going back on our use case where we want to look at the latency of our SaaS applications. To do this, we will change the graph mode of our dashboard to focus on max server latency. And then we see again our pie chart, and we start to see some measurement about latency. In particular, we want to focus on Microsoft Teams. This maybe is the tool we use in our company. So we can just actually first click on conference just to show you how you can interact with the chart. This will apply a filter where we see the conference again, and then the different applications. And then we can click once more on Microsoft Teams. Something I would like you to notice is that clicking around on the dashboard applies filter to it. So we start to see filters appearing on the top side of our dashboard. This changes all the elements, so charts, tables, which are present to the user. So on the right side, we now see again our bandwidth, where we only see the Microsoft Teams, so what we expect by our filter. And we can already do one conclusion here by chance, that given the low bandwidth used by Microsoft Teams, definitely any issue with Microsoft Teams will not be related to a bottleneck in our bandwidth. So that's already some conclusion we can do. Then again, from the table, we will be able to download all the Microsoft Teams trace. But if we want to get maybe a better view of the latency, we can move on the other section of the dashboard. So this latency, click on it. This will expand. And then scrolling down, we have more detailed view on which servers provide this application and how they perform. We see on the top indeed a list of servers, IP addresses, application, their name resolution, their country code. The IOTA is capable to use GeoIP information to localize IP addresses on the world, and then some measurement about the performance of the application. We see by chance that our servers in Asia are not performing that great, probably due to the distance. In Europe, everything looks fine. In USA, we have some mixed result. So by chance, for our investigation, this use case, we can focus on what's happening on the USA state and see if we can get more information about why we have these mixed results. So let's click on USA filter. Again, a new filter has been added to the top side of our dashboard. And now we see that the only dots appearing are the one in USA. We can zoom in on the map, move it around for better visibility. And we see we have these nodes visualized. And we can look by chance at the one which is expressing the highest latency. To do that, we can go back on the table and use the magnifier to apply filters like we have done before. Clicking ultimately on this magnifier, we apply an additional filter. We see we have now one server in our list, the one we have just selected for our filter, and one dot on our map. So at this point, we can already come back to our SaaS provider, telling them, watch out, this specific server is not giving us expected or maybe not ideal performance. What can we do next? We can do probably different things, but one thing we can start with is maybe drill down on the server information, see how much information we can get about this machine. So if we click on the IP address, we will open the host detail dashboard. This dashboard is designed to give information about one specific node of the network, in this case, this server. We can see the information about the bandwidth used over time, and we can also see information about location. Something that may sound strange is why we have these additional dots. And this can be explained looking the right side of our dashboard. We have our IP address, and then we have two host names. This means that our IOTA is capable to detect that those two host names have been resolved to our IP, which may already suggest us that maybe this machine is not serving a single application, a single service, is serving more of them. That's already an additional information we have. But what more? If we click on these names, we can expand them and get additional set of IP, which actually are the IPs we see geolocalized on our map. This gives us another information that our server is probably part of a pool of machines behind a global load balancer for both those applications. And this may give us maybe a hint why some users have experienced these issues in terms of performance and others have not, because based on the load balancer behavior, some have been served by this machine or by others which have different performance. So this is already an additional step in the discovery of the state of the network. Finally, we can look some information about the IP address and about the TCP and protocols, and access the flows of this machine. So we can look at all the traffic flows detected for this machine. And let me show you one thing more. If we sort the flows by duration, we can see this one, 2 minutes. We have two possibilities. Again, we can download the trace, so the PKPNG format file with the packets only of this flow, or we can inspect it further. So if we click on inspect, we will enter in the flow detail dashboard. This offers a view of the details of the communication of this traffic flow. We see that we're talking about a TCP traffic flow and the client, the server, the exchange of packets between them. On the right side, we have the stack where we see from layer 2 to layer 7. And also we see some details about the TLS. We use 1.2, but fortunately in this case, we're using the differential and ephemeral, so all good. We have a view on the packet per second, and finally bandwidth at the bottom, and in the middle some evaluation about the TCP performance. We will see those in more details later, but here we can already have some overview of the performance of the server overall. So we see this flow, we see what type of round trip time has been achieved, the latency measured, and ultimately the total transaction time. So we see a little fluctuation here. Probably we have some data being gathered together. So we have multiple exchange gathered together, and then a small post, and then another set of multiple exchange gathered together. So this is another way we can explore the traffic thanks to the dashboard. Of course, we can always download the flow using our download button on the top right. Now, let me move back on our original dashboard. And as we said, we want to look at the performance in this case. And as we're talking about TCP flows, we want maybe to dig down on the TCP analysis side. To do that, we can use another dashboard. And that's another very powerful feature of the IOTA, is that you can start your data exploration from one view, so one dashboard, apply some filters, and then move to another dashboard with the same filters to continue your analysis. To do that, let me show you briefly. We can remove these application filters for making our, let's say, view simpler. Something I want you to notice is that as already we have discovered, and this is a confirmation of what we saw before, this server is serving two types of application. We have Teams, but also generic Microsoft services. Let's now move to the next, and to the next dashboard. To do that, we click on the navigate button on the top right, and then we select the TCP analysis dashboard. This dashboard, as the name suggests, is focusing on the analysis of the TCP flows. We have some measurement about the performance, duration, some information about the characteristics of the TCP flow, and an evaluation about the flows themselves. If we see this is designed to give us, to highlight if we have some broken TCP connections. We can download this flow again or inspect them. But in our case, as we're looking for performance, let's focus by chance again on bandwidth. We can give a fast look on the bandwidth. Again, we see that in this case is specifically not an issue. And we can move instead on the latency section, where we can start to see through these charts that the RTT by chance for the specific machine has displayed some small fluctuation between 185 millisecond and 155 millisecond. On the other hand, the latency has been quite constant. And ultimately, if we look at the last part of the chart, we can see that the latency per application has been as well quite constant. So it looks like these are the performance expected by the server. So I think we can just come back to our vendor, in this case Microsoft, and tell them, okay, this is the performance we get from the server. How can we improve out of it? And I believe with this overview, just to add the last things, we can use the rest of the dashboard to see TCP flags, zero windowing events, and ultimately retransmission. But yeah, with this, I think we can conclude our first tour around the IOTA GUI. And I don't know if any of you have any question, so maybe we can reply to some of them already.
Yes, we have one question. Can you hear me well?
Now, yes.
Good. Does OS on IOTA has a recovery or SUE accounts?
The IOTA has an internal recovery system that can be used to reset the device to factory settings, or to reset the network settings and the users as well. So it's always possible to recover access to the IOTA device.
I see. Got the point. Thank you.
Is there any other question?
Yes, we have other one. Can we trace a target location and application and separate VPN connections?
Yeah, as we have seen in one of the dashboard, we collect GeoIP information by host. So it's possible to manually apply a filter by country, see the host involved in that specific country as server or as clients, and then perform further filtering on the application overview or on the TCP, or just obtain the trace and do further analysis on different tools. So that's possible.
So we can reconstruct the history data. I see. Got the point.
Yeah.
Good. Also, the next question: can we manage a lot of devices, 100, 200, and how can we automatically update the firmwares?
We are going to soon offer a solution for this use case in the form of a centralized management for multiple IOTAs. And this will allow you to monitor the state of your device, so be able to see whether they're operating correctly and to access the metadata to maintain your devices in, let's say, basic configuration, authentication configuration, but also indeed firmware update, and finally control the units to start, stop capturing, or control any of the device settings. So this is going to be soon available before the end of this year.
Super. And also I see the next one question is, what is the most powerful of IOTA?
Okay, we offer a lot of nice features. I tell you what I think is a very powerful feature we are going to see soon on the next step, is the capability of the device, first of all, to be able to navigate in time back. So as somebody say, you usually don't get issues that are going to happen in the future. You are informed about the issue that has happened in the past. So you can navigate back in time and then use the flow recognition system to identify your problems. And also, and this is something we're going to see on the next demo, we are capable also to cross-correlate between different flows to give to the user all data which belong to a logical single operation. And again, I don't want to spoil it, but this is something we're going to cover in a few minutes.
Clear. Thank you. I don't see any questions.
Okay.
Can continue.
Sorry, I can see one question here. Like it's anonymous, from anonymous. Like users experience decreased performance in database application. Can we check is it caused by network or server, for example, overload server?
We can use the zero windowing information. Unfortunately, I don't have in this sample of I have, because as I said, the data I'm displaying is a snapshot from data we have extracted from our network. But you can use the zero windowing capabilities. So wherever you start to see zero windowing events from the server side, you start to see that maybe the server is underperforming. And that can already tell you by chance that something needs to be adjusted on the server side. The IOTA doesn't only tell you when the zero windowing events are happening, but also gives you an estimation of the recovery time for the zero windowing. And then you can use the TCP analysis dashboard we have just seen to look in the time how the zero windowing events have impacted other latencies. So RTT, server latency, and so on. I don't know if this replies to your question.
Yeah, thank you. If someone of people who come to this webinar have additional questions, please write, or also you can unmute and ask it. Yeah, thank you so much.
Okay, thank you. So I would say if there isn't any other question, maybe we can move on with the next part of our demo. There will be another Q&A session afterwards, and we can get more questions then. So let me move to the next slide. We are now looking at troubleshooting DNS. I expect all of us to be a bit familiar with the important role that DNS has in our IT infrastructure. Is an element which we need to resolve the names, the request, and observing the behavior of of the DNS request can help us to, first of all, highlight if we have specific issues with some applications. So whatever a DNS will start to slow down will definitely impact some of the application operating in our network. But also observing the request sent to a DNS server, we can do some evaluation and inspection of the activity of our network. This can be handy for security reasons. So if we have applications or malware by chance doing activity which we, of course, don't want, but also to see if the users of the network are maybe doing activity that is undesired. So DNS is a very interesting point to look at, and in the IOTA we have designed a dedicated dashboard for it. So let's move to look at it. So this is our DNS overview dashboard. As I already anticipated, it focuses on the DNS request and already provides some evaluation in terms of performance, but not only. But let's go step by step. On the top side of our dashboard, we have a time-based chart displaying the number of requests. These requests are already sorted out by the delay between request and response. So you can filter and display wherever you have slow request. Well, slow request is anything above 500 milliseconds, so definitely user noticeable, and moderate above 150 milliseconds, and finally good, anything below 150. And we can already say, looking at this chart, that our DNS is performing quite well. On the left side, in the middle left side, we have a pie chart instead showing the distribution of the DNS request by DNS server. This can help us to identify whatever we have users which are have configured the system to use maybe DNS servers we are not really happy with, or to overall have an idea where the DNS requests are going on. From this pie chart, it's also possible to perform filtering. So clicking on it with your left button, you get this side menu, and you can apply a filter for DNS request, or go on the details of the host of the DNS server. I'll skip this for the moment just to continue our things, but if you want to play with our device, there's also the opportunity to have a demo access. This is something that we can always arrange. On the right side of our DNS, we have another pie chart with the distribution of the DNS requests to see which are the most common. We don't see anything troubling here. We see some requests probably from machine. We can see we have some good number of Ubuntu machines operating on our network. These are probably coming from some Cisco switch for NTP purposes and so on. But the most interesting part of this dashboard is the flow table at the end. This table called DNS query response with associated flows shows the slowest 20 in terms of delay between request and response. And I think it leverages the killer feature I was highlighting before. So what do we see here? On one side, we have the information about the request. We have request time, the client IP, the DNS server, the query, the response, the delay, and finally the response status, and finally the response, the IP address resolved. But on the right side, instead, we have information about applications flow, which we have detected to be associated with this DNS request. Just to make you an example, to make it maybe easier for you to understand. Imagine you're opening a page with your web browser. So you type a URL, and then you press enter. Your system will first issue a DNS request to resolve the host name. Then, as soon as the host name is resolved, we'll initiate a TCP, TLS, or quick connection towards the server. Now, these two communication are actually independent flows from a point of view of networking. But if you want to troubleshoot the whole communication, it's very important for a network engineer to be able to correlate between them. Now, again, imagine you're operating on a very big data set and you want to be able to cross-correlate these two flows manually. This is going to be very time-consuming. IOTA can do this for you, not only in this dashboard view, but also, again, through the download facility. So you pressing this button, the IOTA will already filter and cross-correlate the flows for you and provide the traffic you want to see, to look at. And this is a very powerful feature that IOTA offers since version 3.0 to our user and enhance significantly the way you can interact and discover your traffic. Another thing you can use of the dashboard is our DNS search on top. Here we can type part or complete host names or domain names and apply this as filter in our board. Like by chance today we're using Zoom. Let's look what we have about Zoom. We write Zoom, all the dashboard is now filtered. We see that all Zoom requests are actually pointing to our internal DNS server. We see the distribution of this request, and here we see something actually quite interesting. We see that overall the DNS resolutions have been quite okay in terms of performance, except one. We see an outliner, 269 milliseconds for a response whenever we try to query this machine, and from this client. What can we do now? We can, of course, download, as I say, the pickup to do the discovery and to see how this has impacted, but we can also actually leverage our dashboard to do that. So what we could do in this case is just, okay, we select the IP address, we copy this IP address. In this way, I can also show you how you can use manually the filters. We move on the application overview. This is the same dashboard we have seen before. And manually, now we can also apply filters by server. Perfect. We have now filtered for the desired server. We see that, of course, this is only serving Zoom. And we can look at our client server side and latency to see, first of all, the latency of the communication of this server. We see that actually this server has been performing quite well, which also means that the DNS delay of 260 milliseconds has a significant impact on the operation on the server from the client perspective. So if a user is coming to us, and actually we can also see which user could come to us. We have 10-10-2013 is coming. If the user behind this machine is coming to us telling us, I've experienced strange behavior at Zoom, we can definitely not blame Zoom for this. We should look into our DNS configuration and settings, first of all. And that's one other way you can use the different dashboards to explore the data. But let me move back. So let me clean the filters and move back on the DNS dashboard, always using our navigation menu. And let me show also how you can use the DNS dashboard and the search DNS to maybe observe or hunt for strange behavior of your network. Recently, we have heard about some significant data leak through Discord. So maybe we don't like, or we want to observe if somebody is using Discord from our company network. So what we can do is maybe type Discord here and see if there is any activity. Then we see that by chance we have some activity based on Discord, the client IP address response. We can download the associated flows, or we can navigate again to the application dashboard, the application overview dashboard for further inspection. And this can also give us really information about the usage of a specific domain name. And I believe with this, we also have covered the functionality of the DNS dashboard and how this can be used to troubleshoot issue related with it. So let me move back on the presentation. And then if there is any additional question on this use case or the previous or anything related with IOTA, we'll be happy to reply. Not sure if there is any question.
Yeah, we have one. Is that possible that we can do a pre-captured filter with IOTA?
Yes, it's possible on the IOTA 10G model, the one with the SFP plus interfaces. It's possible to define L2, L4 filters using masks to filter out, to filter in actually the traffic you want to observe. And that is going to happen a line rate in the hardware before it's been captured. Another opportunity you have if you want to, let's say, discard traffic is to use packet slicing, which will drop the payload of the packet. And this can be handy by chance, of course, to optimize performance on storage, but also to remove data which may bring your IOTA inside some security scope where you don't want to. So that's an additional feature that you can leverage on our IOTA.
I see, thank you. And can you please provide us with use cases, with the most common use cases for IOTA?
Sure. So we already have seen in our presentation some interesting, very common use case. So explore data from TCP perspective, explore data from the DNS perspective or application and so on. But there is maybe another use case very interesting that some of our customers are using with IOTA, and allow me to display briefly. What we can also do is to leverage our VoIP dashboard, which already perform, again, cross-correlation between control traffic and data traffic, in this case, just selecting this, and allow us to have a view of the exchange between the different nodes of the network. So this is another very important use case that our customers are using wherever they need to analyze and monitor VoIP traffic. You can see in this chart specifically, we can also see the exchange of commands in the control and exchange of data at the bottom.
Thank you.
Thank you. Thank you. Thank you so much, Rosario, for your insightful and interesting presentation. It was really great. Also, I'm happy that we're recording it and we will send it to our partners and clients. Gentlemen, if you have any questions, please ask. Jeżeli są jakieś pytania, to proszę, teraz jest taka możliwość zadać to pytanie. Okay, looks that there is no additional questions.
Okay, then really thank you again for this space to present our product and our company. And yeah, looking forward to get additional feedbacks from your customers.
Thank you so much, Rosario. Thank you so much, Profitap team. Thank you to our guests. Yeah, thank you.
Thank you a lot, Rosario.
Thank you. Have a good day.
Have a good day.
Good day.
Bye-bye.
Bye. Are we still recording? I guess so.